I ever wondered why power factor is such a crucial aspect in electrical systems? Well, let's unravel this mystery together. Power factor, in its simplest form, is a measure of how efficiently electrical power is converted into useful work output. It's like the efficiency rating on your home appliances, but for the entire electrical system. This magical number, which ranges between 0 and 1, is a key determinant of the efficiency of power transmission and distribution. Now, here's the kicker. A lower power factor can mean trouble. It's like having a car that guzzles gas but doesn't get you very far. This inefficiency can lead to wasted energy, increased costs, and even potential damage to electrical equipment. Imagine a world where our electrical systems are not performing at their peak, where waste and inefficiency are the norm. Not a pretty picture, right? So, as we can see, power factor is not just a technical term, but a key player in how our electrical systems function. But what exactly is power factor, and how does it work? Well, let's dive right in. Power factor, in its simplest terms, is the ratio of real power to apparent power. Real power, denoted by P, is the capacity of the circuit for performing work in a particular time. Apparent power, represented by S, is the product of voltage and current in a circuit. So, when we talk about power factor, we're essentially discussing the effectiveness of power usage. A power factor of 1, or unity, indicates that all the power is being used effectively. However, a power factor less than 1 signifies that there's some power that's not being effectively used. This unused power is what we refer to as reactive power, denoted by Q. Now imagine you're at a party and you've got a glass of soda. The soda itself is like the real power. It's what you really want. What does the work of quenching your thirst? The foam that forms on top of the soda, that's like the reactive power. It takes up space but doesn't really contribute to quenching your thirst. The total content of the glass, including both the soda and the foam, is the apparent power. In this scenario, the ratio of soda to the total content of the glass would be your power factor. If your glass is all soda and no foam, you have a power factor of 1. You're using your resources perfectly. But if you have a lot of foam taking up space, your power factor decreases. Just like you would want to minimize the foam in your soda to get the most refreshment, in an electrical system, we want to minimize reactive power to make the most effective use of our electrical power. So, when we talk about power factor, we're not just talking about numbers and ratios. We're discussing the efficiency and the effectiveness of an electrical system. We're looking at how well our electrical power is being put to work. Therefore, power factor is essentially a measure of how effectively electrical power is being used. With this understanding of power factor, why would a low power factor be problematic? Imagine a marathon runner. If they're not running efficiently, they'll need more energy to finish the race, right? Similarly, a low power factor means your electrical system isn't running as efficiently as it could be. Let's start with the most immediate consequence: increased energy costs. Just like an inefficient runner, an electrical system with a low power factor requires more power to do the same amount of work. This means higher demand from the power grid and consequently higher energy bills. But the impact doesn't stop at your wallet. A low power factor also reduces the capacity of your electrical systems. Think of it this way. If your electrical system is a highway, then a low power factor is like a traffic jam. It clogs up the system, reducing the amount of power that can flow through at any given time. This might mean your system can't handle as much equipment, or it might struggle to supply power during peak demand times. In fact, a low power factor can even lead to potential damage to equipment. Remember our marathon runner? If they're not running efficiently, they're putting extra strain on their body, which could lead to injury. In the same way, a low power factor puts extra stress on your electrical equipment. Over time, this can cause overheating and premature wear and tear, which can lead to equipment failure. Take, for instance, a factory with heavy machinery. If the power factor is low, the machines may overheat, fail prematurely, or even cause a power outage. The factory then has to deal with the cost of repairing or replacing machinery, lost production time, and potential safety hazards. So, as you can see, a low power factor is more than just a number on a meter. It's a measure of how efficiently your electrical system is running. And if that number is low, it can lead to increased costs, reduced capacity, and potential equipment damage. Evidently, a low power factor can have significant negative impacts on both the efficiency and the cost-effectiveness of electrical systems. So to recap, why is power factor so important? Power factor, as we've discussed, is a measure of how effectively electricity is being used in a system. It's a fundamental aspect of any electrical setup, from the largest power plants to the smallest home appliances. The role of power factor in an electrical system is crucial. A high power factor indicates efficient electricity use, while a low one signifies wastage. This wastage isn't just about energy. It also means higher costs, increased strain on the infrastructure, and potential damage to your equipment. The disadvantages of a low power factor are significant. It can lead to increased electricity bills, reduced capacity of electrical systems, and even equipment failure. Thus, ensuring a high power factor is not just about saving energy, it's about maintaining the health and longevity of our electrical systems. In conclusion, maintaining a high power factor is essential for the optimal performance of our electrical systems. It's not just a concern for electrical engineers, but for all of us who use electricity in our daily lives. With all that said, it's clear that power factor is a topic that deserves our attention. In today's world, where electricity plays a pivotal role in our lives, it's crucial to understand the implications of a low power factor. It not only impacts the efficiency of our electrical systems, but also has financial implications in the long run. Whether you're an electrical engineer, a student, or just a curious mind, don't let the complexity of the topic deter you. Dive in, explore, and learn. There's a wealth of information out there, waiting to be discovered. Remember, knowledge is power, and in this case, it can literally help you use power more effectively. So, don't stop here. Continue your journey of learning about power factor and other electrical concepts. Remember, understanding and improving power factor can lead to more efficient and cost-effective use of electricity. Thank you for watching, and stay tuned for more informative videos on electrical topics.